Hey there, everyone. Mr. Hayden here. I wanted to go over the federal income tax brackets and how they're a piecewise linear function, just like we've graphed before last week or the week before. What their slope is, how you can determine what the equation is by looking at the federal tax table that the Internal Revenue Service or the IRS provides. So we're looking at right here the tax brackets for 2021. I'm sorry, 2020. And what you can see is that up until a certain point of taxable income between 0 and 9875, you pay zero point 0.1 or 10% of whatever the income tax is or whatever your taxable income is. That is the income tax you pay. So if we're looking at trying to graph that, and we're going to make X being the taxable income, and Y, or f of X, being the tax owed, the income tax owed. Well, in the beginning, or whatever these percentages are going to be the slopes values of each little line segment. And each one of these lines or in the tax table is going to be a line segment in our graph. So that means the first line segment is going to have a slope of 12%. The second line segment, 20.22, then 0.24. And as you go, as your taxable income increases, you're paying a greater percentage and since of your income to be the income tax owed. And since the percentages increase as you go along, that means the slope is increasing as you go from left to right on the x-axis. So each line segment is going to have a bigger slope value, just a slightly bigger slope value, and it's going to be continuous. What I mean by continuous is the beginning of the next tax bracket of consecutive tax brackets starts where the other tax bracket ends. All right. So if you make between $40,000 and $85,525, well, you've paid 12% on the first $40,000, but you've paid 10% on the first $9,875, and notice that right at the beginning of the 9875 tax bracket, well, guess what? You've just paid 10% of that, or $987.50. Then the next tax bracket starts off where the previous one ends, but it goes up at a steeper slope. All right, I'm hearing some beeping noises, and I'm hoping I'm still recording, that my audio didn't cut out. Okay, so then how do we write the equations for these lines? Well, these little line segments in our piecewise function, we already know what the slope is for the corresponding line segment. And that slope value is whatever the percent is for that tax bracket. So the next question is, well, if we have the slope and we have a point, we can use the point slope form of a linear equation, substitute in the values for x1 and y1, and sub in the slope value, and then solve the equation for y. So point slope is y minus y1 equals m times x minus x1. All right, and if we know m, x1, and y1 for each of these lines, then we can write the equation of the line. Well, it turns out we will know 2 points for each line based on the information that they supply us. So for the first tax bracket, which is, and it's not 12%, it's 10%, right there. For the first tax bracket, we know at 0 taxable income, you pay 0 in taxes. So that means the first equation, so for the first tax bracket, the equation, we know that 0, 0 is a point on the line, and we know that the slope is 0.1. So we're going to get y minus 0 equals 0.1 times x minus 0, because x1 and y1 are 0, 0. So what does that amount to? Well, if you simplify that, you get y equals 0.1x. So that means that's the equation of this first little line segment, and that's applicable when x is in between 0 and 98.75. Okay, well, how do you do the next tax bracket? Well, the next tax bracket, it turns out we know its starting point. They tell us. So if we make 98.75, okay, we're going to pay 987.50, all right, and plus 0.1 times whatever the excess over 98.75 is. Well, at 98.75, the excess is 0. So that means this point right here, if you look at the tax table, has to have coordinates of a taxable income of 9,875 is what? We pay 987.50. So it turns out that our x1 and y1 are actually this. That's my x1 for the tax bracket. And then, let me see. This is my y1 for that tax bracket. So now we know pretty much all we need to write the equation of each little line segment. The slope for that tax bracket is 0.22, and the point is going to be, let's see, and I'm sorry, I have it reversed. This is x1, and this is y1. All right. So that means for each tax bracket, as I said, the slope is whatever this percentage is, but you'd write it as a decimal. Okay. And then the point that you use to compute the equation of the line in point slope form is the slope, and then a point. And the point is going to be the number here, that's your x1, and the number there is your y1. So, for example, the second tax bracket is going to be the equation of the second tax bracket. Well, the slope is going to be m, which is 0.12. So m is 0.12. x1 is 98.75. y1 is $987.50. So now I have enough info to write the equation of the line. So it's going to be y minus y1 equals, and y1 is, in this case, is $987.50. That's equal to m 0.12 times x minus x1. Okay, so my slope is that, and my, let's see, let me do yellow. My x1 is going to be $9,875. Okay, so now you can just do on your calculator, well, you need to solve for y. So what you'd have to do is distribute the 0.12, and you'd have to use your calculator to do 0.12 times 98.75, and then you would add $987.50 to both sides. So I'm going to get y minus $987.50 is equal to 0.12 x, and then let me do a calculator if I can bring it up real fast. Please be in the list here. Of course it is not. Let me go to this. There we go. So my calculator. Let's see, did it open? Yes. So I need to do let's see, 0.112 times 98.75. So 1185. So that would be minus 1185. And then I'm going to add 987.5 to both sides to move that to get y all by itself. Okay, so I have negative 1185 plus 987.5. So that's going to be, let's see, do I have a plus minus button? Let's go to the scientific version. Okay, so, and now I get 1185, negative 1185 plus 987.5. And that's minus 197.5. So my equation for the second tax bracket is y equals 0.12x, and then what did the calculator say it was? Minus 197.5. So that would be it. That's the equation of the second tax bracket. So what you do to find the equations of all of them is you look at the tax bracket, you use, for M, you're going to try to find what M, X1, and Y1 are. Well, you can read them right out of the tax table. M for a tax bracket is the percentage as a decimal point. And then X1 and Y1 are going to, X1 is going to be the lowest income in the tax range for that tax bracket. So what's in this column here, Y1 is going to be what you pay. All right, so essentially we're finding the first point in that new tax bracket or the end point of the previous tax bracket, but we're going to treat it as the first point of the new tax bracket. You substitute X1 and Y1 and M into the point slope equation, and then you solve for Y. All right, so it's pretty straightforward. That's how you generate the function, the equations of the functions, the individual line segments of the piecewise function of the tax bracket. So if we're graphing X being taxable income and Y being how much tax you owed. All right, so I'm really hoping my screaming boys in the background weren't too distracting, but that was it, and your homework for Thursday is going to be to write the equations of the 22%, 24, 32, 35, and 37% tax brackets. All right, so you'll have to use a calculator to add, you know, like 3 or 4 or 5 digit decimal values, but it's really not too bad. Okay.